So this is one of the tests that one of you guys took, and they just took it just for fun, I'm thinking. So here it is. You'll probably get the same question or same style of question. Sometimes instead of degree, they'll say or radian, but it says find three angles, two positive, one negative, that are coterminal with a given angle. Okay, so 300 degrees is something like right here. So here's 300 degrees. So all you got to do, guys, is go another revolution, and you're back in the same location, because that's what it means to be terminal angle. Does that make sense? So what's one revolution in degrees?
360.
Yeah, so take the 300 and add 360 to that. So let's see, 3 plus 3, that's 600, plus another 60, that's 660. So one terminal angle is 660. So if it doesn't have 660, take it out. Out. Maybe. So that's the only one that's out. Obviously, the correct answer is B because that's what they chose. So I want another coterminal angle. So you take the 660 and you add another 360 to it. See? So 660 plus 300, 789, 960 plus another 60, 1020. So this one doesn't have 1020. Out, and it's between B and E. All right, how do I find the one that's negative? Well, you're going to take this, the 300, and you're going to go backwards. So instead of adding 360, you're going to subtract 360. Does that make sense? So you're going to go 60 degrees, and you're going to go minus 360. And, I wrote 60 degrees. It's 300 degrees. 300 degrees and minus 360. And when you do that, you get negative 60. So there it is. Did that make sense, guys? Okay. Quadrant question 2. It says, name a quadrant in which the given conditions are satisfied. We just started, guys. I'm in question 2. So tan, this means where is tan negative? Tan is negative in this quadrant and in quadrant 4. And this means secant. Where is secant negative? Secant's a reciprocal of cosine. So cosine is negative in quadrant 2 and quadrant 3. So there it is. Which one has both of them? Quadrant 2. So this person got it wrong. It's letter B. And ask me questions if we have any questions. Are we still okay, guys?
Can you explain that?
Yes. This tan means where is tan positive? Remember that tan is y divided by x. So where is y divided by x negative? In quadrant 2 and in quadrant 4. Because the y's are negative in quadrant 4 divided by positive x. And then this, the secant less than 0 means where is secant negative? Now remember, secant is a reciprocal of cosine. So wherever you have x's that are negative. X's are negative in quadrant 2 and in quadrant 3. So which one has both of those? Quadrant 2. Let's see if we're going to have enough room for this one. Let P of x denote the point where the terminal side of an angle theta meets a unit circle. If P is in quadrant 2 and x equals negative 5/9, evaluate the 6 trigonometric functions. Okay, so I'm going to do question 2 right here, guys, because I have space right here. So here's my grid, and here's my unit circle. And it says that x is negative 5/9, so from the center, go like that. Here's negative 5/9. The radius of a unit circle is 1. So I need to figure out what the y value is. Right? So here we go. I'm going to call that y. X squared, I already know what x squared is, negative 5/9. Negative 5/9 squared plus y squared equals 1 squared. So when I square this, 25 over 81 plus y squared equals 1. Subtract it from the 1, so y squared equals 1 minus 25 over 81. Are we still okay? Okay, turn that 1 into 81 over 81, and then you get this. Y squared equals 81 minus 25, 81, 71, 61, 50, 46. Did I get that right? Over 81. 81, 71, 61, and then minus 5. Nope, 50, 56. Did I do that right? 81 minus 25. 81 minus 25. Yeah, 56. All right, so 56 over 81, does that reduce? Math frac. Nope. I'm going to take a square root because I want y. Square root. Y equals square root of 56 over over 9. Now 56 is 9 times, what's 56? 8 times, man, why am I having a bad day today? 56 over x, second table. All right, perfect square root. Here it is. 4 times 14 is 56, and the square root of 4 is 2. Do you guys see that? So this is the same thing as 4 times 14, so I can write this as y equals 2 square root of 14 over 9. Okay, now we're ready. You can take a seat, miss, if you want. Or, okay, all right, whatever you want, miss. Okay, because the radius is 1, remember that we said cosine is just the x value and sine is just the y value? So I'm just going to go over here and I'm like, okay, look, letter A, delete, because this one has cosine being a positive 5/9 out. I need it to be a negative 5/9. So maybe letter B, let's see, letter C, delete, maybe letter D, and letter E, delete. Do you guys see why I deleted all those? Okay, so now it says, don't worry about the cotangent. I guess we'll get to it if we don't figure it out. Remember that for sine, we got 2 square root of 14 over 9. So that's what I'm going to look for sine. So I'm going to go to sine. And look, that one has negative 2 square root of 14 over 9. So maybe. And this one has, okay, you know what? Why did I put maybe? That one has a negative in the front. That one's out. It's letter D. Do you see how we got letter D? Come on in, man. Come on in. Yeah. You see how the y value is in quadrant 2? So we need to have a positive value. So it needs to be a positive 2 square root of 14 over 9. And letter B had sine be a negative 2 square root of 14 over 9. But I need it to be in quadrant 2. So look at letter D. Letter D has that one.
But wait, because when you like do the movement and stuff, it's like 25 over 81 minus 1. So like, how did you get like the 81?
Okay, say it again. I did 81 minus 25, which was 56.
Yeah, but like, how did you get there?
Oh, I just moved the 25 over 81 to the right, and it was 1 minus 25 over 81, and then the 1 I turned it into 81 over 81, because that's 1. So then 81 minus 25 is 56. Common denominator 81. Then I take the square root because I wanted to get y by itself, not y squared. The square root of 81 is 9, and then 56 breaks down to 4 times 14, right? So the square root of 4 is 2, so 2 square root of 14 over 9. Does that make sense? And then of course, if both of them were to match, then you start messing with the x and the y divided by, we're in quadrant 2, so cotangent and tangent better be both negative. Notice letter B has cotangent to be a positive, so letter D has cotangent to be negative, so there it is. It has to be letter D. And we saw how we canceled everything, right? Okay. All right.
You're saying for ring ceremony, right?
Yes. It starts at 6 o'clock. Okay. All right, ready for this one? Okay. Rewrite the following expression in terms of referential sum from the appropriate sign. Okay, before you do anything, this is cosecant 247. 247 degrees is in what quadrant? Third quadrant. It's something like over here. In quadrant 3, is cosecant going to be positive, negative, or like cosecant's reciprocal of sine? It's going to be negative. So I'm going to use the reference angle. Here's my reference. I'm going to put a negative cosecant. CSC, and I need that reference angle. So how do I get it? 247 minus 180. So let's see, 47, 57, 67. So that's 67 degrees. So there it is. I put the negative in there because I'm in quadrant 3. Because everything in quadrant 3 is going to be negative. Well, everything except for tangent and cotangent. You know what I mean? So if I put cosecant of 67, just a cosecant 67, that's going to be positive because it's like in quadrant 1. But put the negative in the front to make it the same as cosecant 247. That makes sense?
Yes.
Okay. You guys ready for the next one? All right. Sine 4 pi over 3. So they want the same thing. Rewrite each expression in terms of reference angle. Well, 4 pi over 3 is something like right here. So the reference angle is this guy. That's pi over 3. Again, what did you tell me about sine or 4 pi over 3? Is it going to be positive or negative? Negative. So put a negative in the front. Sine of pi over 3. And there it is. Oh, nope, that's not a negative. There it is. Do you see what I'm talking about? Because sine of pi over 3 will give you that negative. I mean, sine of pi over 3 is going to be a positive. It's square root of 3 over 2. But I want it to be a negative answer, so I put the negative in the front. Because sine of 4 pi over 3 is negative square root of 3 over 2. Okay. Do you get it, Clark? Or are you just telling me that? You get it? You okay? Don't worry, miss. Yeah, ask me questions, please. Find the quadrantal angle, negative pi over 2. Give the coordinates to the point where the terminal side of the angle intersects for the unit circle. Then give the cosine and sine of that angle. Okay, relax. All that means is, do you know where negative pi over 2 is? It's right here. It's that axis right there, right? So a negative pi over 2 on the unit circle. What's this coordinate? 0, negative 1. So the first thing you're going to do is delete, delete, maybe, delete. Do you see how it's between A and D now? All right. Then you say, what do they want? They want cosine and sine. Cosine's the x, sine is the y. So cosine of negative pi over 2 is 0. Sine of negative pi over 2 is negative 1. There it is. And that's what I'm looking for. How do we feel? Okay. Can we go to the next one?
Yes.
Okay. Find the exact value of the following expression. Do not use the calculator of undefined, state undefined. Okay, what this means arc sine of negative half. This means sine of what angle is a negative half. That's what it means. And we haven't talked about the domain of inverse functions, but for sine, you really should be looking between negative pi over 2 and pi over 2, because that covers all the y values. See, these are the negative ones below the x-axis, and above the x-axis is a positive one. So what angle do I have a negative half? At this angle right here. What angle is that? Negative. That angle, because I went clockwise, that angle is negative pi over 6. Do you see that? So negative pi over 6. Do you feel okay, guys?
Yes.
All right. Again, this means the same thing, guys. This means cosine of what angle is a half. So on the unit circle, you cover all the x values, positive and negative, between 0 and pi, see, for cosine. So I'm only going to look in between 0 and pi. So where is cosine a half? Well, that happens right up there. What angle is that? Pi over 3. This person got it wrong. It's pi over 3. See? Good job, guys. I know, it's not the most exciting stuff in the world. I know. All right, question 9. Find the exact value for arctan of 1. So here's my unit circle. Tan will give you all the values between negative pi over 2 and pi over 2. Or is it between 0 and pi? I'm trying to remember. No. Tan y divided by x is 0. Yeah, that's correct. All right, so where is it 1? It happens right smack there. That angle, remember, because that coordinate is square root of 2 over 2, comma, square root of 2 over 2. So that angle is pi over. Get some sleep today, miss. Don't worry, I'll do the same. We all got to get sleep. You know, as a matter of fact, don't even do any homework tonight. Just go to sleep. And tell your teachers it's mental health time, that you didn't do any homework because of mental health.
I wish.
No, if you guys were to tell me, probably should not record this, right? Well, if you're watching this, I guess that's fine. If you tell me, if you come to me, you swing and you come out here and child, I wanted to sleep yesterday, so I fell asleep and didn't do the homework. I'd probably be like, you know what? That's fine. Go ahead and take care of it today, because I care more about you. I care about you guys. I don't care about some number. You know, be healthy. Go to sleep. Go to sleep early. All right. So this means cosine of theta equals square root of 2. This is not possible. This is not possible because cosine theta has to be between -1 and 1. So square root of 2 is a bigger number than 1. So undefined. Not possible. There's no angle that will give me square root of 2. I'm almost done. Miss. So give me like 10 more minutes and I'll be done here. Hey, Wentz. did they come to you about the rumor?
I heard there was some massive shade thrown around.
It wasn't shade. I was just like, hey guys, guess what I heard? I heard Wentz doesn't really like Star Wars. No, that we were joking. Everyone knew that was a joke. They all laughed.
They all came in there and they were like, guess what we heard? You're a fake fan. And I'm like, fake fan of what? And they're like, Star Wars? And I'm like,
see, I can't do I can't remember how we were talking yesterday? I can't do it while I'm teaching, but if I'm not teaching, I can so okay, I'll stop. All right, guys. So this one hopefully should be pretty easy for you guys. Ask me.
Can you go back to the other one?
Yeah.
I don't know. I don't see what you mean.
Yeah, on the unit circle,
Yeah.
cosine is a ratio, and the biggest cosine is going to be is 1. And the smallest cosine is going to be is -1. And it has to be between -1 and 1. That square root of 2 is a number bigger than 1. You can't be that. Like, it just can't. It's not possible.
Can you like figure that out if you like say that all the cosines will make square root of 2?
None of the cosines. We have cosines that are square root of 2 over 2,
Yeah.
but it doesn't, like, square root of 2 over 2 is a number smaller than 1.
Yeah.
But square root of 2 is a number bigger than 1. And you can't have that. If you were to try to put, I know it says do not use calculator, but if you were to type,
Would square root of 2 be like a second revolution?
no, square root of 2, okay, square root of 2 is just a number. Square root of 2 is that number, 1.41. But you can't beat that. The radius is 1. Remember that this is a ratio, x divided by y. So the biggest cosine can be is 1. You can't be bigger than 1. So the fact that it says cosine is equal to square root of 2, like, that's not possible. Not possible. There is no angle that will get you square root of 2. No angle. I mean, there's square root of 2 over 2, but not square root of 2. You know what I mean? So you can't be that. Okay, find the period of the function. Really simple. Check it out, guys. Look how simple this is. Here's 0, point of inflection going down. Look for another point of inflection going down. 2 pi over 3. So 2 pi over 3. Do you see how fast we did that? Okay, let's go to the next one. Find the amplitude. Okay, well, where's the middle? It looks like the middle is right smack on the x-axis. So the amplitude is the distance from the max to the midline. So 3. 3. Do you see how fast that was? Okay, let's go to the next one. Find the period. Okay, well, I see a b. Remember that the b is 2 pi divided by period. So then that means the period is 2 pi divided by b. Do you guys remember that? So I'm going to go 2 pi divided by 1/3. Keep, change, flip. 2 pi times 3. So 6 pi. Do you see how we did it, guys? Okay. We're almost done. Don't worry. Look at question 14. Find the amplitude. Well, the amplitude is just the number in front of the what?
In front of the cos.
Yeah. So there it is. 5, 6. Do you see how we're doing it? All right. Question 15. Find the period. Find the number in front of the x. So the b, that's your b. B is pi over 4. And I'm just doing the same thing we did last time. Period equals 2 pi divided by pi over 4. So 2 pi times 4 over 5. Keep, change, flip. 8. All I did was keep, change, flip. Find the amplitude. Again, find the amplitude is just the number in front of the... Yeah. So it's 5. Are we okay, guys? All right. Question 17. Find the phase shift. All right. This is probably the hardest one in here. It is not pi to the left because you have to factor out a pi over 5. See? You got to make it look like this. A cosine B, open parenthesis, x minus c, close, plus d. It needs to look like that. So factor out the pi over 5 like this. Pi over 5, parenthesis, x plus. Well, if I factor out a pi over 5, so that means I'm going to have a 5 right here. See? Because if you distribute pi over 5 times 5, that's pi. Do you see that? So it moves 5 to the left. That makes sense? 9 cosine pi over 5 x plus 5 close plus 3. So there it is, 5 to the left. Yeah, I just factor out power 5. So see, when you factor out a power 5, if I distribute this power 5, I better get a pi. So pi over 5 times 5, look, that's just pi. See? So that's like the hack that you're like, oh, well, what do I do to get a pi by itself? Well, I guess you got to factor out, well, I'm factoring this out, pi over 5. And to factor out pi over 5, let me see. Oh, I guess I have to have a 5 there because the 5s cancel out and you get a pi if you distribute. See, so you got to kind of have to think backwards. Don't worry, you don't have to think alone. You can let the answers help you out. You know, like plug it in and like, oh, this is the only one that's going to give me a pi if I distribute. If I plug in that 5, oh, there it is. So it has to be 5 to the left. You know what I mean? Later, Dennis. Okay. Find the vertical shift for the following function. Okay, what's my vertical shift? No, the vertical shift, just whatever that number is. That's, remember that we called that the midline and you're, yeah. Oh, you were saying it's E, right? Oh no, sorry, it's 2 down, B.
Yeah.
Sorry.
Oh no, I'm saying like in the equation, not the answer.
Oh, the D. Got it. Yes. Yeah, A, B, yeah. Are we okay with that one, guys?
Yes.
Okay, UH writes it a little funny. It's fine. Remember, we talked about how different, says, which of the following could represent this? Okay, before I do anything, find the midline. The middle is -1. Do you guys see how the middle is -1? So delete anything that does not have -1. Out, and out. So it's between B and C. All right, next. Look where I have, let's look at the amplitude so you don't even have to worry about finding the C. From -1 to 1, what is that gap? No, that's not 3. 2. So look for an amplitude of 2. There's only 2 options. Which one is it? B. There it is. Okay. Last one. All right. Look, and you don't even need to do anything. Last question. You guys ready? Where's the midline? Where's the middle? -1. If it does not have -1 at the end, out. It's between B and D. Notice they both have different amplitudes. All right, well, what's the distance from 1 to -1? So which one's the answer? There it is. Do you see how we did it, guys? Is this pretty easy? Yeah, can we get 100 on this? Yeah, let me know what questions you missed, and that's it, guys. We're done. Good job.